Okay, so I'm only going to put one up on this slide because this is a really big one, a really important one. So arenes, now technically they are arenes, but usually they get referred to as aromatic compounds. That's generally the common thing. And we're gonna spend or at least a fair amount of time on arenes and aromatic compounds later in the year. Essentially what that means is that you have an aromatic ring in it. You have a ring structure that's a hexagon, which means 6 carbons, 1, 2, 3, 4, 5, 6. And that there's double bonds, there's a resonant delocalized structure there in the middle. I know that we probably briefly covered that if you took AP Chem. You'll see it referred to as either this or as this. And obviously that's the base structure, so that means that it could just be that's aromatic, or then we could draw all kinds of R groups off of that. We could put halogens off of it. We could put long chains of carbon off of it. We could do it at each of the 6 locations. If there's that ring in there and there's the delocalized electrons in there, it's an aromatic structure. All right, so now we're going to get into some functional groups that are what we would in many cases call derivatives of carboxylic acids. In other words, they have similarities to the structure of carboxylic acids, but they in and of themselves have some different reactivity and functionality that in some cases is similar to carboxylic acids, in some cases not. So acyl halides, again, we've got the carbonyl group, but instead of the hydroxyl group coming off of that same carbon, we're going to have a halogen. Just like before for the alkyl halides, that could be a chlorine, it could be a fluorine, it could be a bromine, an iodine, all that sort of thing. Those are acyl halides there. Okay, so some chain, carbonyl group, terminal again, and then some sort of halogen there at the end. In hydrides, you'll see the similarity to a carboxylic acid group. Like if we cut this off here and put a hydrogen, that would have been a carboxylic acid. But instead, it's almost like you've got 2 of them doubled up, or you've got like a combo of like 2 ketones and an ether, regardless of how you want to say it. And a hydride is where you have this group in the middle. What does that group in the middle mean? Carbon, carbon. The 2 carbons are bonded together with an oxygen, and then each of the carbons has a carbonyl group coming off of it, and then there can be whatever chain or whatever is necessary coming off of that. That is our example of an anhydride. All right, so for our last 2 carboxylic acid derivatives, we have esters and amides. Again, you see the similar structure that it looks like a carboxylic acid in many ways. You've got the carbonyl bonded to, in this case, an oxygen, but then there's another chain. So we said with carboxylic acids that they had to be terminal for them to be carboxylic acids. If that carboxyl group, if the double bonded oxygen on the same carbon as a single bonded oxygen is not at the end of the chain, but rather in the middle of the chain, that's what's going to make that an ester. So in this case, you see that there's a chain going on. We're in the middle of it. There's not a hydrogen there on the end. That hydrogen, by the way, obviously is what would make a carboxylic acid acidic. That's the proton that would be given off. That's not true here, so esters are obviously going to be different, even though they very much look similar to a carboxylic acid. Amides, the difference here in an amide is that you have replaced your oxygen with a nitrogen. So not the double bonded oxygen, not the carbonyl part, but the one that would have gone into a hydroxyl group of carboxylic acid is now a nitrogen. You could have chains coming off of that nitrogen as well, and you often do. In this case, I didn't put any actual chains. They're just hydrogens there on the end, but that's an amide structure. So last of our major functional groups are amines. You'll notice that both in amides and amines, we have a nitrogen in there. Nitrogen is sort of our 4th element that pops up a lot of times. We've got carbons, hydrogens, you've seen a lot of oxygens, and then we'll see some nitrogens in quite a few compounds. An amine essentially means that you've got a nitrogen in there and that there's some chains of hydrocarbons at some point branching off of that. It could be one chain and there's a nitrogen at the end and then there's some hydrogens. It could be, as in our example here, that there are 2 chains and a hydrogen. There could obviously have been 3 chains as well. The amine means that there is the end there. And you can sort of, if you're tying things together in your brain and sort of relating things to biology and biochem, as you will hopefully do here, you can easily see how we could take an amine and combine that with a carboxylic acid and get our good friends, the amino acids that are going to be so important to us. All right, so that's it for functional groups, at least for the major ones. Thanks a lot, kiddos.